Hi there! Now we will have a code practice for machine learning quality evaluation. For doing that, I'm going to show you the example I create with help of Jupyter Notebook, because it's very widely used tool for data scientists and some data engineers as well, who is interested in model training and some experiments with data. So I opened up my Jupyter Notebook locally, and I suggest you to do the same. Prior to running Jupyter Notebook, I would also suggest you to create a virtual environment, because we are going to use quite a lot of libraries for machine learning and data analysis, and in order to avoid future conflicts of libraries version, and especially if you do have quite a lot of projects where you also use such libraries, it's better to kind of isolate it in the virtual environment. So I already created my one, and today I'm going to use some standard libraries like NumPy, Pandas, scikit-learn, and also evidently, and I'm a maintainer, so this is the library which is created to help you with the evaluation of data quality and machine learning model quality, as well as the testing and monitoring machine learning services and pipelines. So here is the link to open GitHub repo. Let me show it to you. Pull requests, very interesting, but let's go to the main page. Here it is, and here you can find the instructions on the installation in the README. Here it is, and as evidently is the Python package, it's fairly simple. So just go for pip install or conda install, and you will get the package. If you're interested, of course, you can also build it from the source code. For doing this, follow the instructions from contribution markdown. And I'm going to move back to the example. So if you need some time to install evidently, or maybe other libraries like Pandas, NumPy, scikit-learn, please take a short break and do it, and then come back to us. I will start from the adding title to our example. Let me do it. And we will need to import a couple of libraries. It will be Pandas, NumPy to work with the data, and as we are going to play around with machine learning quality reports, we need to have a model and to a dataset, so I'm going to use scikit-learn, and I will need to import a couple of things from evidently. Let's do it. Now we have all the code imported. Now, as I discussed with you before, we need to create machine learning models for classification, regression, and create the data samples with the features, models output, and target value. Those will be the source for creating machine learning quality reports for classification and regression. So let me quickly import the data, load it to the Jupyter Notebook and create the data frame. I will start from classification, and for classification I selected breast cancer toy dataset from scikit-learn, so no need to transfer any files, any databases. It will be just imported with help of simple Python function. So what I did so far, I just imported load breast cancer dataset in the data frame format, and I created two random samples, one for reference data and one for current data. My reference data will contain 300 rows, and my current data will contain 200 rows, right? And now I need to create a model so that we can solve classification problem, and I will use random forest classifier from scikit-learn, because random forest classifier is actually Bayesian type of model, so I will now need to run a lot of experiments in order to find the normal model, because that's a Bayesian, so it's robust against overfitting, and I can just select the number of estimators, I believe 10 will be enough, and play around with this model. Of course, for more practical cases, it makes sense to run some hyperparameter search and conduct a lot of experiments, right, in order to find out which is the best machine learning algorithm for your problem statement. But as our main focus is evaluation part, we use toy dataset and pretty simple baseline. So my one is random forest classifier. Now let me fit the model, generate models output, and write it down to my pandas data frames. So now let's do some debugging. Okay, so what we did so far is we trained our model on top of the reference parts of data, and then we just called predict proba methods from our model so that we can get not only labels but predicted probabilities. And well, this predict proba returns to us a list of two columns, predicted probability for the 0 label and 1 label, and we took, with help of this small command, predicted probabilities for our target class, so for label 1. Now let's take a look how our data looks like. And well, we can see that we have quite a lot of features, and finally our target and prediction, which is quite good. So now let me prepare as well the dataset for the regression, and we will move to the model quality report calculation. As we discussed, for regression we are going to use California housing dataset, which we can also load from scikit-learn. What I want to do now is create a target column so that it will be easier to work with the data frame, and for doing that I want to just quickly make a preview of our data frame. So let me take the last column as the target. This time, instead of training the real model, I decided to create a simulated predictions, so just to entertain you a little bit. And our prediction will be our target value with some random error, which is normally distributed with the mean equal to 0 and deviation equal to 3. So that will be our prediction. And now, finally, let's generate reference and current part of our data, because we need also to have two samples, and move for model quality reports generations. For doing reference and current parts of the data, here I will just create the random samples. Now I like how it looks. So basically we have a dataset which contains features, our target and prediction. And now we have two datasets, one for regression and one for classification, and we can move on to the report generation. And for doing report, I'm going to use evidently. So I need to create a report. For doing that, I imported report object from evidently before, and I will start from classification preset, which is also imported from the evidently metric preset part. So, okay, let us start. Okay, I will generate report object, so I will call it classification performance report. So here it is. Basically, I created the report, and now I need to specify which metrics I want to include in my report, because basically the report contains the information about the analysis results, and I need to specify what kind of analysis I want to have here. So let me start from the preset, because in evidently we have not only metrics but also metric presets, which are a good combination of metrics to tackle specific problem statement. In my case, my problem statement is probabilistic classification, so I can just start from the classification metrics preset, and then I can analyze it and decide what metrics I like, what metrics I do not like, and create a custom report containing only metrics I want to see in my report. So let me start from the preset now. Yeah, now it's much easier. So here is my classification preset, and let me now run our report on top of our prepared dataset. For doing that, I'm going to use method run and then method show in order to see the results inside of Jupyter Notebook. Basically, here it is. I just called method run and passed my reference and current data there, so that's easy. And now I want to explore the results of my calculations right there inside of my Jupyter Notebook. This is why I call method show to show the results, and my mode in what I want to show the result is inline, so right there in Jupyter Notebook. And let me run this cell, and here is the result. So you can see that it's quite nice visual report out there. Let me open up. The report started from the metrics, that's classification quality metrics for our dataset, and we see some metrics for the current data: accuracy, precision, recall, F-score, area under the receiver regression curve, and log loss, and same for the reference, so you can quickly grasp what is the quality of your model. And then there are quite a lot of visualizations. For example, that's one for class balance, right? And we can check the absolute and percentage values so that we can compare. There are quite a lot of other things like confusion metrics, like quality metrics by class. There is class separation, so you can see how good you separated the class, and many others. So if you're interested, please feel free to explore different metrics and visualizations, because we do have a lot in evidently. Well, good. So now I want to quickly show you that together with the default values, you can actually pass different parameters into the metrics preset and metrics in order to specify how exactly you want to analyze your data. For example, here for classification preset, we have probabilistic classification, and sometimes you can not only use default threshold, which is equal to 0.5, but maybe we want to have our custom threshold, and this is perfectly possible. So let us pass the custom threshold and see the metrics. Previously measured metrics, and let me now pass the threshold. For example, let it be equal to 0.7. And well, now you can see that the values of metrics are now changed because we just used our custom threshold. And that's our report again. Well, that's quite convenient. Now you saw what are different metrics you used here, and maybe if you want to specify some exact metrics, or maybe just get rid of some metrics you don't really need, you can create your own custom report. Let me just copy code from here in order to speed things up a bit. But now, instead of classification preset, I'm going to use the exact metrics. So let me come up with my own list of metrics. So yeah, now I'm happy because probably I selected all my favorite classification metrics. So let me now run this cell. Here is our customized report, and this report is much smaller because we have only few metrics, which is model quality, class representation, confusion matrix, quality by class, and probabilistic distribution, right? So that's how you can specify what metrics you want to include into the report. And of course, you can create a custom metrics, which is not the topic of our today's discussion, but maybe later I'm going to show you the example, or at least drop a link on the custom metrics. So that's how we can explore the quality of machine learning models here inside of Jupyter Notebook. And this is very convenient when you do some ad hoc analysis, or maybe do some debugging when you saw some issues with models quality during the experiments or during the monitoring. And well, it's quite convenient for ad hoc analysis, but what if you need to, for example, share the results of your analysis with your colleagues who are domain experts but not really big fans of Python? In this case, it's good to somehow create the standalone separate file with the results and share it to your colleagues, and that's also perfectly possible. For doing that, instead of method show, we are going to use method save. Let's see how we can do that. So here we are. I just called save HTML method and passed the classification report HTML name, and now I am going to save it and see the results. So I just called it classification report. Here it is, and you can see in the browser that it's very same report here. So that's how you can conveniently share it with your colleagues and teammates. Now let's move on. So we see how we can create the report inside of Jupyter Notebook and show it with our colleagues and friends. Sometimes it's not our main goal, because if you need to automate something, for example, log somewhere classification quality metric after you run a specific step in your deck, for example, or maybe if you want to decide on what should be your next step in the deck depending on the model's quality, you might want to have not the visual results of the evaluation, but rather some text files or maybe Python objects. And this is also quite easy to achieve evidently. For doing that, I would go for my calculated report again. But now, instead of method save or show, I'm going to use method JSON. That's how you can perfectly get the results of evaluations in the JSON format, and this is very convenient if you want to log it somewhere, for example, to some database or object storage or wherever you store your historical data, so that's quite convenient. Of course, together with JSON, we have save JSON, so if you want to generate a file, you can do that. And finally, let me show you sdict methods as well. These methods generate for us Python object, which is dictionary in our case, and that's very convenient if you want to create some logic, like maybe Python functions or conditional run of the task from your deck, depending on some values from this report. For example, depending on the precision, which is here, or maybe depending on the recall. And it's very easy because that's the Python dictionary, right? So you can access any value by keys, right? And based on this value, you can implement any conditional logic. So this is quite convenient for your decks. And well, probably that's all I wanted to share with you regarding the classification quality evaluation. Now let's move to the regression one. So I created a topic, and now let's create the regression quality report. It will be very similar to what we just did for classification, but instead of classification performance preset, we are going to use regression preset. So let's start from the object creation. Well, looks like here it is. So what we just did, we created the report object, we specified the metrics, which is regression preset, then we called methods run, and we passed housing reference data with sorted index and current reference and current housing data with sorted index, because previously we just did some random sampling, right? And well, finally we called the methods show. And here is our regression performance report. Again, it started from the tabs with quality metrics. Here they are. It's you who decide whether you like the quality of the model or not. then some predicted versus actual plot, which is quite useful in order to see whether your model is following the pattern and how close your predicted values are to your actual values. Also, there are quite a lot of plots related to the quality of your regression model, so like reference, not reference, it's current, and second one is reference, so that's actual and predicted data. So we can switch on and switch off some data and see. It's very interactive, so you can really zoom in and explore any specific region of your model, for example, closely. And also you can create and download any like picture if you want to, for example, input it into your slides or use somewhere else. So that's very interactive, and you can do pretty a lot of different things with the visualization. So yeah, that's predicted versus actual data. Here is also an error. It's like predicted minus actual values. There is also absolute percentage error, which is sometimes quite useful. Error distribution, so that you can see whether your model tends to underestimate or overestimate the demand, right? And well, error normality, and quite a lot of other visualizations. And here again, very similarly to what we just did for our classification model, you can come up with your custom list of regression metrics. Let us do it as well. So I will copy some instructions. Very nice plot, I believe. No, it's not enough. Let me copy all the instructions from here. So I'm going to speed things up a little bit, and I'm going to find like 3 to 4 metrics I like. Well, I would start from regression quality metric. Then, for example, regression error plot. And I will end with regression error distribution because I like this plot. It helps to like check what is the model error. And well, I'm going to run it. And here we have our customized report, which includes only 3 metrics. Right? So that's basically how you can create a report in HTML format or JSON format in a format of Python dictionary, and then act based on what you see or what you have in the report.